Thanks for staying with us, for always being part of our channel. We still want to continue our series of teaching on binary operation. We want to continue our series of teaching on binary operation. Now, in this lesson, we are looking at identity element. Identity element. The identity element is also known as neutral element. So in exam, if you are asked to calculate identity element, it also means neutral element. So they can call it identity element or neutral element under binary operation asterisk. Now, how do you find the identity element or neutral element in binary operation? The condition for a binary operation to have identity element should be, take for example, if the operation is asterisk, let's say you have S asterisk Y. For this S asterisk Y to have an identity element or a neutral element, S asterisk E must be equal to X. This condition must be fulfilled. To have S asterisk E must be equal to X, where this E is what referred to as the identity or neutral element. And the identity or neutral element in a binary operation is always unique. What we mean by the identity or neutral element in a binary operation is always unique is that it must always be a constant, devoid of the other elements or alphabet, as the case may be. So if the operation is S asterisk E is equal to X, what you are going to have should be either 1, 2, minus 1, or 1 over 4, 1 over 2 over something, devoid of the other elements. Now let's look at this example and find the identity element. Now you have a binary and operation triangle on the set R of real numbers is defined by A triangle B is equal to 2A minus 1 over 2 plus B. Find for all A, B is an element of R. Find the identity element in R. We want to find the identity element in this R. How do we do that? The operation that you are given is A triangle B, and the set is equal to 2A minus 1 over 2 plus B. Now for this binary operation to have an identity element, A triangle E must be equal to A. A triangle E must be equal to A, or A operation E must be equal to A. What does that mean? It means that this one will still serve as my A, but this B now will serve as my identity element, and in this place, and it should be equal to A. That is, anywhere I see A in this operation, I'll put A, but anywhere I see B now, I'll put E, and the expression should be equal to A. So let's watch as I substitute my value here. So you have 2, which is this 2 now. Then this A is serving as my A, minus 1 on its own, everything over 2, plus, instead of writing this B now, the B will not serve as my identity or neutral element. So plus E should be equal to E, should be equal to this A. So if I solve this now to get my E, E is here, then I can collect like terms with the whole of this one. That will be A minus 2A minus 1, everything over 2. Then this over 1. If I find my LCM, my E, LCM of this and this is 2. So 2 divided by this, that's 2 divided by 1 is 2 times A. You have 2A minus 2 divided by 2 is 1. Open bracket, 2A minus 1. So if I simplify further, my E will be equal to 2A minus 1 times 2A is 2A, minus times minus is plus, 1 times 1 is 1, everything over 2. Then my E will be equal to 2A minus 2A will cancel out. I will have 1 over 2. So my identity element in this binary operation now is 1 over 2. You see the answer, the identity element does not contain this A again in the answer. So this binary operation has identity element. If for every question that you solve, for any question that you solve, you have E and see how the alphabet attached to it, then that binary operation has no identity element. But for this one, my identity element is 1/2. Please stay tuned to our channel because we are bringing more examples on identity element for better understanding. Bye.